Today we're going to solve exponential equations with common bases. And actually, if you look at my notes, I highlighted the word common basis because that's the important part of what we're doing when we solve equations for this. But the other nice part about this stuff is that we can, when we solve an exponential equation, look at the rest of the directions. Verify the solutions by plugging the values for x back into the original equation. So we can check these and know that we got them right or wrong immediately. And I will check some of them as we go through on these problems, and some of them I won't spend the time on. But that's the nice part about this problem. Common basis. Luckily, we've already seen something where we've had to deal with common bases a little bit. And you've got plenty of space on problem number 1. So off to the side, I'm going to write 81. And let's break it down, and let's see if we can get it broken down into threes. But we are pretty familiar with the fact that 81 is 9 times 9, which then is 3 times 3, and 3 times 3. So what we want to do is we want to rewrite these equations with common bases. One term on the left side of the equation, one term on the right side, eventually. But right now we have 3 to the x plus 1. And over here, 81 is 3 to the 1, 2, 3, 4. So now we have a common base of 3. And it's not really canceling out, but what works for a lot of students is if they cancel out the 3's. We're going to ignore the 3's. They're never going to change into a different number. They're going to remain 3's. So what we need to do to solve this equation is we need to look at the exponents now. And it's x plus 1 equals 4, and we can subtract 1 from both sides. We get x equals 3. But the underlying concept here is, can we find like bases? And it's going to come back to, do we know some of our exponent rules as well? Because in problem number 2, we see a 5 on both sides. So we're almost with common bases. But we need to get that fraction out of the problem. At least it will be easier if we get that fraction out of the problem. And because it's a fraction, what we can do is we can rewrite the right side of the equation by using a negative exponent. We're going to flip, because this is 5 to the first power, we're going to flip and change the sign of the exponent. And it's 5 to the negative first. And already I'm just realizing that I didn't check my work on that last one, so we need to make sure to check our work on this one. But once we've found common bases, we see that we have a 5 on the left, and we have a 5 on the right. Those are already the same. So what we need to work with here are the exponents, which are x plus 3 equals negative 1. Well, we subtract 3 from both sides, and we come up with x equals negative 4. But what I said earlier, even though I didn't do it, is let's go back and check. We can know immediately that we've got the problem right or we've got the problem wrong. And what it is it's 5 to the, and we just got the answer of negative 4, so it's negative 4 plus 3. When we press enter, we get 0.2. But if we go to math, enter, enter, we see that 0.2 is the same thing as 1/5. And that is what's on the other side of our equals. We know that we have this problem correct. I tend to like to say whatever the main concept is over and over and over again. We want to get these problems into like bases. And problem 3 is a little bit more complicated than the previous two, but we've got the idea now, so we want to apply it a little bit more. So let's take this number of 125 and let's break it down. And what we know here is 125 is 5 times 25. And we can break down 25 a little bit more into 5 times 5. And once we do that, we can write this equation in terms of like bases. We have 5 to the x squared plus 8. And over here, 125 is the same thing as 5 cubed because we have 1, 2, 3, 5. So when we simplify 125, 5 times 5 times 5. But don't overlook the fact that 125 is raised to the 2x. So we saw an exponent rule in problem number 2. We see an exponent rule in this one, I hope. You know that I like the superpower idea. What the superpower idea says is that we need to multiply those two terms that I just circled in blue. So we have 5 to the x squared plus 8 over here on the left side of the equation. And on the right side we have 5. 3 times 2x is 6x. And now we have it in the format so that we can actually solve for x. Because the 5 on the left isn't any different from the 5 on the right. We're going to use the exponents to help us solve. X squared plus 8 equals 6x. There's an x squared in this problem, which means that we're probably going to have to factor. And in order to factor, we need to have the equation set equal to 0. So let's move this 6x over to the left side. We have x squared minus 6x plus 8 equals 0. And let's factor. When we factor, it's 1 times 8 is 8. And the factors of 8 are 1 and 8 and 2 and 4. And will either of those combine to be 6? And it's going to be the 2 and the 4. And in fact, more specifically, it's going to be negative 2 and negative 4. And we're going to split them out. It's going to be x squared minus 2x minus 4x plus 8. Well, when we look at this first group here, and then we've got our second group, the greatest common factor in our first group is x. And then we're left with x minus 2. In our second group here, it's minus 4. Negative 4x divided by negative 4 is x. 8 divided by negative 4 is negative 2. And now what we have is we've got x minus 2 here and x minus 2 there. It's x minus 2 times x minus 4 equals 0. And I hope that you can tell me that x equals 2 and x equals 4 and you don't need to do any of that extra work. I know I'm going to do it, but I hope that you can just say x equals 2, x equals 4. If you can't, there's nothing wrong with that. We take x minus 2 and we set it equal to 0. We take x minus 4 and we set it equal to 0. And we add 2 to both sides. X equals 2. And over here, we add 4 to both sides. And we get x equals 4. We happen to have 2 answers to this problem because there was an x squared in there. But when we go back to check this answer, which we're going to do right now with our calculator, when you type it in, just only type in the 2's. So the first part is it's going to be 5 to the 2 squared plus 8. And we get that number. And then on the other side, it's 125 to the 2 times 2. only put the 2 in. And luckily what we see here is that both sides match. We can do the same thing with the 4. 5 to the 4 squared plus 8. And we get that value. Big long decimal in scientific notation. And then when we compare it to the other side, 125 to the 2 times 4, and we get the same value. So there are our solutions, and we know that they're both right because we were able to check it in our calculator. Underlying theme. Like basis. And in this particular problem, now we've got a 9, we have a 27, and we have a 3. And the lowest value of those 3 numbers is a 3. So can we rewrite 9 in terms of 3? And you should be thinking yes. Can we rewrite 27 in terms of 3? Yes. If you need to, come off to the side here, and 9 is 3 times 3. And 27 is 9 times 3, which is 3 and 3. So when we go back into this problem, to rewrite it, 9 is 3 squared. Don't forget, that's raised to the 2x. And we're going to multiply that by 27, and off here to the right, we just figured out that 27 is 3 times 3, 3 times 3 times 3. So 27 is 3 cubed. But don't forget, it's to the x squared. And we don't need to do anything over here on the right side of the equals, at least not yet. Common basis. Turn the equation into common basis whenever you can. Now that we have that, we're going to go back to our superpower rule, which says that we're going to multiply those 2 values together. And we're going to multiply these 2 values together. And when we do that, we end up with 3 to the 4x, 2 times 2x, 3 to the 3x squared. We're multiplying 3 times x squared equals 3 to the negative 1. And still, we need to think about our exponent rules. We're multiplying 2 values together that have common bases. Well, what do we do to the exponents when we multiply? Remember, a to the m times a to the n? We need to add the exponents. So over here on the left side, we have 3 to the 4x times 3 to the 3x squared. We're going to add those values together. What we turn it into is we've got 1 term on the left side of the equation and 1 term on the right side of the equation. I don't want to delete that. Ah, yay. Thank you. Ooh, but it was recording now, so that'll be interesting on the video. So now, we've got a 3, 1 3 on the left side, 1 3 on the right side. We can ignore those values. They don't really cancel out. But what we're going to use to solve is we're going to use our exponents, which is the 4x plus the 3x squared equals negative 1. I'm going to change the order over on the left side so that it's 3x squared plus 4x. And let's also move the 1 to the other side. And once again, we need to factor. And this time we have a number in front of the x squared, but we're still going to split the middle. 3 times 1 is 3. And luckily, the only factors of 3 are 1 and 3. And will 1 and 3 combine to be 4? Yes. So we fill that back in, and we have 3x squared plus 3x plus 1x plus 1. By the way, you could have written the 1x first and the 3x second. It doesn't make any difference. I just thought it might be nice to put the 3's together and the 1's together to factor. Because now our greatest common factor in the first group is 3x. And we're left with x plus 1. And our greatest common factor in the second group is 1. And we're left with x plus 1. And now, we've got x plus 1 from each group. And then we have the 3x plus 1. And once again, I hope that you can tell me that x equals negative 1, that x equals negative 1/3. If you can't, that's okay. We've got x plus 1 equals 0, and 3x plus 1 equals 0. Subtract 1 from both sides, and we get x equals negative 1. And then subtract 1 from both sides, and we get 3x equals negative 1. And divide both sides by 3. So x equals negative 1/3. Again, we could type these in to our calculator, but only use the negative 1 for the whole equation and make sure that both sides match. Then only use negative 1/3 for both sides of the equation and make sure that they both match. I'm not going to take the time to do that at this point here. I want to keep moving forward. For problem number 5. Now we have e's. Remember that e is an irrational number. I believe it's 2.7182818281828 ... So what we're going to be solving for here on this problem is x, but we need to put it in a proper format so that we can solve. And the nice part is that there's only e's in here, but we can simplify a little bit more. And it's, in this problem, it's e to the negative x squared. Over here, we're going to superpower on that first term over there on the right side. So it's x times 2. It's not x squared. When we superpower, we multiply those together. So it's going to be x times 2, also written as 2x, times 1 over e to the 3. Well, we saw this concept on example number 2, where we had to flip and change the sign in the exponent. So 1 over e to the 3 is the same thing as e to the negative 3. We flipped and we changed the sign on the exponent. So it's in a little bit better format. We need to combine the right side down into one term of e. So over here on the right side, when we multiply, remember we add the exponents, and I'm going to do an extra step that you may or may not need. But I want to emphasize the fact that when we multiply, we add the exponents. So it's going to be 2x plus a negative 3. Again, some of you don't need to write that step. You may have just gone directly to the fact that it's going to be e to the 2x minus 3. Just like the other problems, even the past two examples here on the same page, we have an e on the left side and an e on the right side. They're never going to change into a different number. So what we need to be concerned about to help us solve is we need to figure out this exponent term. And it's negative x squared equals 2x minus 3. We have x squared in here. We're going to have to factor. The thing about factoring is it's a lot easier to do if your x squared term is positive. So let's add the x squared to the right side. And we get 0 equals x squared plus 2x minus 3. And without spending the time on factoring this time, we've got x, and 3, and 1, and plus, and minus. Once again, I hope that you can tell me that x equals -3 and x equals +1, and you don't need to show me any of the work. Nothing wrong if you do need to show the work. X plus 3 equals 0, x minus 1 equals 0. Subtract 3 from both sides. We get x equals -3 and x equals 1. If you do take the time to check it, and at least on a quiz, I recommend it, but only put -3 back into the problem to check. And then only put 1 back into the problem to check. If you have a fraction button on this particular problem, it's probably a little bit easier to check. But only do one answer at a time. I'm going to skip example number 6 and finish up with example number 7. Notice there's 3 practice problems on the bottom of this page. But as we look at this one last time, the whole theme of solving exponential equations is common basis. If we can possibly get it into common basis, that's our easiest step. And once again, it's helpful to know that 81 is 3 times 3 times 3 times 3. So we can rewrite as 3 to the 4. Don't forget that there's a 3n plus 2 here. 243 happens to be 81 times 3. And we just saw that 81 is 3 times 3 times 3 times 3. And then we've got one more 3. So down here in the denominator of this problem, this is going to be 3 to the 5th to the -n. And luckily enough, over here on the other side, it's already taken care of it for us. So 3 is the smallest number in that problem, so we hope that we can write everything in terms of 3. We need the superpower. We're going to superpower here. We're going to superpower here. And superpower means that we need to multiply those exponents. So this becomes 3 to the 4 times 3n, which is 12n. 4 times 2 is 8. Down here in the denominator, 5 times -n is -5n. And that still equals 3 to the 4th. Now, there's a couple of different ways to do this problem, but what's the exponential rule when we divide? What operation do we do when we divide? And we do a to the m divided by a to the n equals a to the m minus n. So this is going to be 3 to the 12n plus 8. I'm actually going to write it in minus our denominator exponent, which is -5n. 2 negatives together, but that gets everything out of the fraction minus the -5n. And now that still equals 3 to the 4th. Well, double negative gives us positive. We have 3 to the 12n plus 5n, which is 17n, plus 8 equals 3 to the 4th. And finally, what I've done quickly here is that we have a 3 on the left side and a 3 on the right side. We don't need to worry about that. Luckily enough, we don't need a factor on this one. We don't have any squared term in it. We just have 17n plus 8 equals 4. We are going to get a fraction for our answer. But we subtract 8 from both sides. And we have 17n equals negative 4. And finally, it's 17 times n. Our inverse operation is to divide by 17. And we end up with n equals negative 4/17. If you check that in the calculator, you will find that the left side of the equation will match up with the right side of the equation.